Okay, next we're going to do problem 9 of 2.3. That is finding the missing term needed to make a trinomial. Square of each of the following problems in here. Okay, so what's in this box? Well, we know our rule is that 2 times, erase this, 2 times the square root of the first term times the square root of the last term, when you've got them written in the correct order. 2 times the square root of the first times the square root of the last will equal whatever, it will just equal that box. So our answer is 2xy. 2xy for that one. Okay, let's do problem 10. It is 9a squared minus something plus b squared. Okay, we know our rule is that 2 times the root of the first term times the root of the last term will be that box. So let's just say that's 2 times 3a times b. So 2 times 3a, I'm just going to write it out so you can visualize it. That's 6ab. That's our answer for 10. Alright, let's do number 11. 25y squared plus something plus 81z squared. Notice these are called perfect square trinomials for a reason. These are perfect squares. 25y squared can be easily rooted down to 5y. This one can be easily rooted down to 9z. That's why they're called perfect square trinomials. So we know our pattern is that 2 times the root of the first term times the root of the last term, okay, equals that box. That'll be 2 times 5y times 9z. That's 2 times 5 is 10. 10 times 9 is 90. 90yz is the answer for 11. Let's do number 12. Okay, that is 16x squared plus something in a box plus y squared. Okay, that, let's just write it out how we've been doing. 2 times the root of this one times the root of the last one equal my box. Okay, 2 times 4x times y. 2 times 8xy is my answer. 8xy would be in here. And think about it, that's that really makes that pattern we'd always been talking about. It's 2 times 4x, it's 8x times y. That's y. There it is. That's that perfect square trinomial pattern. Okay. 13, 4 plus something plus 9m to the 4th. This is a perfect square. This is a perfect square. Yes, we're used to seeing our first term having a variable instead of our last, but really it doesn't make a difference. We can work this one right here. Our box is going to be 2 times the root of 4 times the root of 9m to the 4th. So that would be 2 and that would be 3m squared. So we've got what is in our box. That's going to be 12 m squared is going to be in our box. So you could think of it like 4 plus 12m squared plus 9m to the 4th, or you could write 9m to the 4th first. Anyway, we filled in the blank. We did what we were supposed to do. Okay, number 14. 9 minus something plus 4a squared b squared. Okay? 2 times the root of 9 times the root of 4a squared b squared. Up until now, I hadn't really been addressing the fact that when I'm rooting these, it's really the root of, say, 4 would be plus or minus 2. It's been working out because I've had all plus problems so far. But, or well, that one was a minus problem. Oh, well, they worried about the sign for me, so. But anyway, well, I suppose it doesn't matter yet. Okay. Sorry about that. Okay, let's keep going. This will be 2 times 3 times 2ab. Yeah, they worried about the sign for me. Something was going on in my head. I don't know. Okay, 2 times 3 is 6. 6 times 2 is 12. 12ab would be our answer. I didn't have to worry about how they made that negative 12ab. You know, if I were finding one of these, I'd have to worry about it. You know, what I'm talking about is what was my sign in here. There would have been a minus sign. This is a perfect square, so they're the same thing in each parentheses. There would have been a minus sign in here, like that. That way, when I worked it out, the middle term would have been a negative, but the end term would have been that positive 4a squared b squared. Okay. Alright, so anyway, let's move on though. 12ab is our answer for number 14. Alright, let's go to number 15. Number 15 is c squared minus 2cd plus something. So now we're worrying about our end term. Let's just do, we know our middle term, okay? Let's do that same kind of rule we were doing. The middle term is 2 times the root of c squared times the root of that box. I'm going to set this up like an equation. 2 times the root of this side times the root of this side equals what's in here? Negative 2cd. So let me just really isolate what I don't know. We're used to isolating x. Well, today we're isolating the box. So anyway, 2 times the square root of c squared. Divide this one by 2 times the square root of c squared. Alright, so the square root of my box that I'm finding equals, let's see what we can cancel out of this one. That box right up there, I'm just going to simplify this. That's a negative 1 times a 2 right there times a c times a d over a 2 times a c. So my 2's will cancel out, my c's will cancel out. I'm left with negative d. So the square root of my box is negative d. But for my answer, I need to find what's just the box. So get it out from under that root, like that. So my box just equals d. It's good to know that the root was a negative d. That's how it was a negative on the middle, just like we talked about. So if I were factoring this, then I would, worry about saying c minus d times c minus d to factor it, knowing it was a negative. That was nice to know, but I'm just finding the squared version of it. So my box answer is D.